Welcome back. Today we are diving deep into the architecting scale. We often talk about databases as a single block, but when you hit massive scale, you need to tear down that routing layer and look at the wiring. We're going to explore how we partition and shard our way to high performance system. Before we start, if you're finding these technical deep dives useful, please hit that like button, share, subscribe, and with your engineering team. Also make sure to visit www.bitbytoken.com. Whether you're looking to master software, data, AI, or machine learning engineering, our site has the foundational concept and system design blueprints you need to level up your career. This is what it looks like. This is my site, bitbytoken.com. These are different components. You can navigate through it. It has fundamentals and example solution. Anything that you want to figure out, let's say you want to look at indexing, those are broken down by basic, advanced, and expert topics. Okay, do explore this out and share your feedback with us, how we can make it better. Now, let's jump onto our architecture now. Okay, the monolith bottleneck is very real. A single database instance has a physical limit. There is only so much a pipe available to your queries and writes. When you hit that ceiling, you can't just throw more hardware at the problem. You have to get surgical. You need to split the logic, not just the data, to keep your system responsive. The key to this is routing engine. The magic here is that your application layer remains completely oblivious to the complexity underneath. The routing engine is the steering wheel. It uses a partition key to dictate the exact destination of every row, ensuring data is distributed without your app ever needing to know the difference. Range partitioning is our first strategy. Think of it as putting data into chronological buckets, perfect for logs, events, or answering simple questions like what happened last week. It's ordered, continuous, and highly intuitive for time series workloads. The real superpower of range partitioning is partition pruning. When a query comes in, the agent doesn't scan the entire database. It looks at the criteria, immediately eliminates irrelevant partition, and only touches the one that matters. We don't scan everything. We just ignore the noise, which saves massive amounts of I/O. But here is a danger zone, the right hotspot. Range partitioning has an Achilles heel. If all of your new data is current, then 100% of your new inserts are hitting the exact same partition, while the rest sit idle. Eventually, that one partition saturates, latency spikes, and your system begins to degrade. It's a classic performance trap. When you need categorical isolation, you will use list partitioning. This routes data based on discrete human readable values. This is your go-to strategy for multi-tenant SaaS or when you have strict GDPR requirements that demand physical data residency for specific regions. Warning: watch out for unmapped values. If a new category appears that isn't defined in your router, the system will throw a fatal error. A pro tip for a senior dev: always define a default cache or partition, but monitor it closely. Don't let it become a graveyard for a bad data that you forget to manage. If your goal is a uniform distribution, reach for hash partitioning. By taking the hash of an ID modulo the number of partition, you spread the load perfectly evenly. This is ideal when you have millions of users and you just need to ensure no single partition gets overwhelmed. But here's the catch. Standard hash partitioning destroys data locality. If you need to perform a range query, the database is forced to scan every single bucket. Plus, if you need to add a new partition, you're looking at a massive, expensive data reshuffle. It's brilliant at runtime, but painful to manage at scale. To handle real-world complexity, we use composite partitioning, the multi-level tree. We apply two strategies in sequence, like partitioning by range at the top level and hash at the second level. This is the workhorse for enterprise system, giving you the best of the both worlds. Under the hood, the composite approach allows for time-based range pruning combined with uniform right distribution. A well-designed composite scheme can eliminate up to 96% of irrelevant data for a typical point lookup. You get efficiency and scale simultaneously. But be careful, complexity explodes. Every layer you add multiplies the number of leaf partition you have to monitor and migrate. If you try to do this on a small 10 million row table, The operational overhead will bury you. Only apply these advanced patterns when your scale truly demands it. To wrap up, here is the architect matrix. Use range for time series, list for categories, hash for even load, and composite when you need high write throughput and time-based queries. The golden rule is simple. Choose your partition key based on your most frequent query and always stress test it against your write patterns. What's the biggest scaling challenge you have faced? Share your stories in the comments below and don't forget to like, share, and subscribe and hit that bell icon for your next deep dive. Until next time.